Understanding structural load distribution in a building. So before we start, if you are new to this channel, please subscribe the channel and press the bell icon so you will be the first to know when I upload something new, and follow me on Facebook, Instagram and Twitter for latest updates. Now let's get started. Understanding structural load distribution in a building. Structural load distribution is critical in ensuring that a building can safely support and transmit loads without falling. Loads in buildings are forces that needs to be properly accounted for, such as the weight of the building itself, occupants, furniture, wind, and seismic forces. The first type of loads. So what are the type of loads? There are different type of loads that a building structure must bear, and they are categorized as: first is dead load, DL. Dead load refers to the permanent load on the structure. It includes the weight of the structure itself, walls, roofs, floors, and any other fixed components like partitions or permanent fixtures, which are non-movable. These are permanent loads. For example, weight of concrete, bricks, steel, etc. These all are permanent loads. Next, live loads, LL. This is the temporary load imposed by occupants, furniture, or movable objects in the building. Example, people in the building, furniture and equipment. These are movable. So these are live load because these loads are movable. These are not permanent load. Dead load is permanent load and live load is temporary loads. Next, wind load, WL. The horizontal pressure exerted by wind on the building surface. It affects tall buildings significantly, requiring designs to resist sway and pressure from wind forces. This is wind load. Next, seismic load, SL. Forces acting on a structure during an earthquake. Seismic load is also known as earthquake load. Usually we say seismic load. Forces acting on a structure during an earthquake. These loads cause horizontal and vertical movements and require specific design considerations in earthquake-prone areas. Other loads. Snow load, rain load, and thermal loads may also need to be considered based on the building's location and environment. Except all live load, wind load, seismic load, dead load, other loads are coming like in the form of snow, rain, and thermal loads. These loads also coming on the building. So we have to consider this as per location and environment. Next, load path. How the load goes. Load path is the route the load takes from where it is applied to the ground. Okay, load path is the route the load takes from where it is applied to the ground. How the load is going to the ground. Understanding this path is key to ensuring that the building can safely transfer these forces without failure. Point of application. Loads are applied at different points on the structure, for example, on the floor, walls, or roof. So loads may come from floor, from wall, or from roof slab. So next, load transfer elements. Load transfer elements include beams, columns, walls, and foundations that distribute the load to the ground. The typical load path in a building follows this sequence. This is the sequence. See? Floor, roof slab. So either floor or from the roof slab, the load is going to beam. Okay, if it is ground floor, then from the floor the load is going. If it is first floor, then from roof slab, the load is going to beams. Okay, to beams. Then from beams, the load goes to columns or walls. Then from columns or walls, it goes to foundations, and from foundations, it goes to ground. So this is the load path in a building. Each element in this sequence must be designed to safely carry and transmit loads to the next element. Next, primary structural elements. First, slabs. Slabs distribute loads horizontally to the supporting beams or load-bearing walls. They primarily bear live loads like furniture and people. Next, beams. Beams are horizontal elements that carry loads from the slab and transmit them to columns or walls. Beams resist bending and are a critical part of the structural load path. Key concept: a beam span and load carrying capacity depends on its size, material, and the load it needs to support. Next, columns. Columns are vertical elements that carry the load from the beams and transfer it to the foundation. Columns bear compressive loads and are crucial for the vertical load path. Key concept: columns should be strong enough to support loads without buckling. Next, load bearing walls. In some buildings, walls rather than beams and columns are designed to support loads. Load bearing walls carry the loads from the roof and upper floors to the foundation. The load bearing walls, the house which has load bearing walls, so it is designed without beams and columns. So there it is designed to support loads. Load bearing walls carry the loads directly from the roof and upper floors to the foundation. Next, foundation. Foundations distribute the loads from the building to the ground. The type of foundation, shallow or deep, depends on the soil type and the loads to be carried. Key concept: the foundation must be strong enough to transfer the entire building's load without causing excessive settlement or shifting. Next, load distribution concepts. Uniformly distributed load, UDL. Loads that are spread out evenly across a structural element such as the weight of a floor slab being uniformly distributed to supporting beams. Point loads. These are concentrated loads applied at specific points such as heavy masonry shifting on a slab. These loads create localized stress on the structure. Design considerations. Material strength. Materials like concrete, steel, or timber have different capacities to resist loads. The material selection is crucial in determining how loads are distributed. Factor of safety. Every building must be designed with a factor of safety to account for unexpected loads or errors in construction. This ensures the building remains safe even under extreme conditions. Load combinations. Engineers combine different type of loads, dead load, live load, wind load, etc., using safety factors to design structural elements that can resist all possible loads simultaneously. Understanding load bearing and framed structures. First, load bearing structures. In load bearing structures, walls carry the entire load of the building, transferring it to the foundation. I have already told this. In load bearing structure, wall carry the entire load from the building and transfer it to the foundation. These structures are commonly used in smaller buildings or homes. Now, framed structures. In framed structures, loads are carried by beams and columns, allowing for more flexibility in design and the ability to build taller structures. Vertical versus horizontal load distribution. First, vertical loads. These include dead loads like the weight of the building and live load like people, furniture. They act downward and are transferred from slabs to beams, columns, and foundation. Okay. Horizontal load. So in vertical loads, first the load is going from slabs to beams, then from beams to columns, and from columns to foundation, and from foundation to it's going to ground. So in horizontal load, wind and seismic loads exert horizontal forces on the structure. Lateral load resisting systems like shear walls, bracing, or moment resisting frames are used to handle these loads. Understand different load types. It's important to recognize the types of loads acting on a building, such as dead loads, permanent weight of the structure, live loads, occupant furniture, wind loads, and seismic forces. Next, follow the load path. Always trace the path that loads follow from the point of application through slabs, beams, columns, and foundations down to the ground. This ensures stability. Know the role of each structural elements. Slabs distribute loads to beams, beams transport loads to columns or walls, columns carry these loads to the foundation, and foundations spread them to the ground. This you should know role of each structural element. Okay, first slab. From slab, load goes to beam. Then from beam, load goes to column or wall. Then from wall, column carry these loads to foundation. Column or wall, it transfer the load to the foundation, and the foundation transfer the load to the ground. Next, select appropriate materials. Choose building materials based on their strength and load-bearing capacity, like concrete for heavy loads and steel for tensile strength. Design with safety factors. Every structure must include a factor of safety to handle unexpected increases in load or minor construction errors. Account for both vertical and horizontal loads. Vertical loads come from gravity, dead load, and live loads, while horizontal loads arise from wind or seismic forces. Both must be considered in design. Use load combinations. Structures need to be designed to resist multiple loads acting simultaneously. such as wind combined with dead load and live loads. Differentiate between load-bearing and framed structures. Load-bearing structures rely on walls to support weight, while framed structures use beams and columns, providing more flexibility and allowing for taller buildings. Understand load distribution methods. Be aware of how loads can be spread across a structure, such as through uniformly distributed loads, UDL, or point loads. And use lateral load resisting systems. For horizontal loads like wind or seismic activity, structures may require special systems like shear walls or bracing for extra stability. So these points ensure safe, efficient load distribution throughout the structure. And by understanding these principles, you will ensure better design, safety, and efficiency in construction projects. So I hope you found this video helpful. And if you found this video helpful, please like, share, and comment. Thank you for watching the video.